Entropy. You hear that word all the time, right? It's used everywhere, from science class to movies, and it's almost always about the universe just falling apart into chaos. But what if that's not really the full picture? What if we've been looking at entropy all wrong? Well, today we're going to dig into that idea and see things from a whole new angle.
Yeah, this is the idea we all know. It's this notion that there's some kind of unstoppable force pushing everything toward disorder. A clean room gets messy, a hot coffee gets cold. It all just seems to break down. It's a simple and pretty compelling thought. But here's the big question, the one that changes everything. Does slapping the label entropy on something actually explain the why behind it? Or is it just a fancy word we use to describe what we see happening anyway? This is the core puzzle we're going to try and solve. So our source material comes in with a pretty bold kind of contrarian take. It argues that the way we commonly think about entropy, the role we give it, is, well, just totally misunderstood. It's like we've given it this incredible power that it doesn't actually have. And there it is, the central claim, laid out plain and simple. Let that sink in for a second. This completely flips the script on us. It suggests that when we say something like, entropy made the ice cube melt, we're not actually explaining why it melted. Nope, we're just describing what happened. So if entropy isn't the cause, what on earth is it? Okay, to really get why entropy can't be an explanation, we have to pull back the curtain and see how it's actually built. See, it's not some fundamental force we just discover, like gravity. It's a concept we construct, and it has to be done in a very specific three-step order.
It's a strict recipe. Step 1, you have to define your objects. Step 2, you define all the possible ways those objects can be arranged. We call those states. And only then, after you've done all that prep work, can you get to step 3, calculating entropy. So let's break that down, starting at the very beginning.
Everything, and I mean everything, starts right here. Before we can even begin to talk about the order or disorder of a system, we first have to agree on what that system is actually made of. This isn't a small detail. It's the foundation for everything that comes next. So, what are we looking at? Is our system a collection of individual atoms, or are we looking at bigger things, like molecules? Maybe even grains of sand? The critical thing to realize is that we, the people doing the observing, are the ones who make this choice. Before a single bit of math happens, we have to draw a line in the sand and define the fundamental parts. All right, so we've picked our objects. Let's say we're dealing with a handful of atoms. Now what? Well, the next step is to figure out all the different ways those atoms can be arranged in the space they're in. Think of a state as just a single snapshot, a freeze frame of the system. Imagine you have 4 atoms in a little box. One possible state is all 4 of them huddled together in the top left corner. Another state could be 1 atom in each of the 4 corners. Every single unique arrangement you can think of is its own distinct state, and it's all based on those objects we chose back in step 1. And only now, after we've defined our objects and listed out all their possible states, can we finally bring entropy into the picture. See how it only shows up at the very, very end of the process? It's not the starting point at all. And here's the big reveal. Entropy is just a number. It's a mathematical value, that's it. We look at all those states we defined, we figure out the probability of each one, we run it through a specific formula involving a logarithm, and poof, out comes a value we call entropy. It's not a physical force, it's the answer to a math problem. This quote from the source material just hits the nail on the head, doesn't it? It puts it so clearly. The description has to come first. You can't just have entropy floating around in a void. It doesn't mean anything until you first define the objects and the states of your system. And this brings us to the real aha moment of this whole thing. This is the fundamental mix-up between what entropy actually does versus what we often think it does. It all boils down to the huge difference between description and explanation. So let's look at this. An explanation answers the question, why? It gets to the root cause, the actual force making something happen. A description, on the other hand, just answers how. It's an observation of what's happening based on probability. Now, where does entropy fit? Well, according to this, it lives squarely in the description column. A great way to think about it is that entropy is like a weather forecast. The forecast can tell you there's a 90% chance of rain tomorrow. It's describing a highly probable outcome, but the forecast itself isn't the force that causes the rain. The real why, the explanation, is in things like atmospheric pressure, temperature gradients, and humidity. Those are the real forces doing the work.
At this point, you might be thinking, okay, that's an interesting distinction, but so what? Why does this really matter? Well, it matters a whole lot because it completely changes how we should approach looking for answers in science and in the world around us.
So let's boil it all down. The next time you hear someone talk about entropy, just remember these key things. First, it's a mathematical tool, not some cosmic force pushing things around. Second, it just describes what arrangements are the most likely to happen. It doesn't cause them to happen. And finally, if you really want to find the why behind something, you have to look past the statistics and find the actual underlying forces and laws of physics that are doing all the heavy lifting.
And that's really the thought I want to leave you with. If entropy is just a map that shows us the most likely destination on our journey, then what's the actual engine that's driving the car? Finding that engine, that's where the real explanation lies.